She is the NASA's Icarus. Fortunately, the research probe, Parker Solar Probe, did not melt its wings when it recently came into close contact with the Sun again. While the spacecraft had already approached our host star to within 13 million kilometers in 2023, it's now set to break its own record by flying within 6 million kilometers of our mighty giver of warmth and life. And indeed, the data collected by Parker Solar Probe on its mission does show our star in a completely new light. But how is this even possible? How can a probe head to such a cosmic furnace without instantly burning up? And how did it even manage to crack a tantalizing solar wind conundrum that has stumped experts since the 1960s? For most of us, the Christmas holidays are a time for cozy reflection, but Parker Solar Probe was to spend Christmas Eve a little differently. After all, December 24th, 2024 was a day of records for the spacecraft. On the one hand, NASA announced that its Sun Striker had reached an incredible speed of around 690,000 kilometers per hour, making it faster than any other man-made object through space. And on the other hand, that this breakneck course had brought the probe to within 6 million kilometers of the Sun. This meant that it had achieved a new solar approach record, but it would take until December 26th before NASA experts were able to give vent to their cries of joy. Specifically, there was radio silence for a day after the sensational flight, but the signal that arrived at the U.S. Space Agency on Boxing Day confirmed that Parker Solar Probe had survived its grip on the Sun unscathed and was working as desired. And so it came to pass that the probe was able to start transmitting the first telemetry data to Earth just in time for New Year's Day. And in a mission update the next day, NASA announced that Parker Solar Probe's scientific instruments were also completely intact. Furthermore, the dataset showed that the programmed commands from the flight computer had been successfully executed. But what groundbreaking new insights were hidden in the new data? After all, Program Manager Helen Winters of Johns Hopkins University in Baltimore emphasized that the spacecraft was making observations that no one had ever been able to make before. Well, the somewhat sobering answer, however, is that the information collected by Parker Solar Probe is currently still a closed book. But fortunately, not because of an unforeseen transmission error, but simply because the rest of the data will not arrive on Earth until the end of January. This will only happen once the most powerful onboard antenna is better aligned with our earthly home in order to transmit at higher rates. And while the experts are currently waiting with bated breath for the results of this hot rendezvous, a glance into the future also gives cause for astronomical anticipation. Parker Solar Probe is scheduled to make 2 more visits to the Sun this year, approaching our mother star on March 22nd and June 19th at roughly the same speeds and distances. A look back in time shows the remarkable insights the probe has already provided about the Sun, and that it has literally been seen in a new light ever since. How Parker Solar Probe will survive its flight to the Sun. It is no coincidence that the solar probe bears the word Parker in its name. After all, the U.S. astrophysicist Eugene Parker attracted attention as a young man in the 1950s when he put forward a mathematical theory explaining the existence of the solar wind. In simple terms, this refers to the stream of charged particles that the Sun constantly emits into space. And while Eugene Parker died in 2022 at the age of 94, he was the first person to witness the launch of a probe named after him. In fact, Parker Solar Probe had already set out into the vastness of space on August 12, 2018. But how did it come to be on its way to the Sun, of all things, and why hasn't it burned up already? Well, regarding the mission's goal, we must not forget that there are still some big question marks surrounding the Sun. This concerns, in particular, the questions of why the solar corona is so incredibly hot, and how the solar wind is generated and what makes it so fast. While the heat scheme of celestial bodies like the Earth points from the inside outwards, or in other words, the temperatures decrease more and more from the core to the outer layers, the Sun has a confusing second heat zone with the corona. But what causes the outer atmosphere of our host star to have a temperature of around 1 million degrees, over 200 times hotter than its surface? Since the second law of thermodynamics states that heat flow from the cooler to the warmer is simply impossible, the fiery corona must be based on something else, and the heat must arise within it in some way. But since the experts ultimately realized that they would not be able to crack this mystery in their earthly research stations, they decided to send a spacecraft directly into the solar corona with Parker's solar probe. The fact that it did not follow the Icarus's footsteps and turn into a pile of ashes is thanks to a few exciting factors. First and foremost, there is the fact that temperature is not the same as heat in physical terms. While temperature only refers to the kinetic energy of particles and measures how fast they move, heat describes the amount of energy transferred by the particles. And in the solar corona, each plasma particle that is chasing around has an incredibly high temperature. But since there are very few of them at the same time, Parker's solar probe will ultimately have to withstand temperatures of only 1400 degrees Celsius. This is achieved with the help of a large heat shield made of carbon foam and carbon plates, which has been given a white and thus particularly reflective ceramic coating. To ensure the protection of the other components, NASA experts have once again used special materials such as special alloys and sapphire conductor tracks, whose melting points are well above the expected temperatures. What Parker's solar probe has discovered about the Sun. In 2021, the time had come. Parker's solar probe approached the Sun to within 13 million kilometers and plunged into its corona multiple times. And while the record-breaking flight understandably made international headlines at the time, revealing, among other things, that the surface of the corona is not uniform and smooth, but characterized by local peaks and valleys, these were by no means the first findings of the mission. 2 years earlier, the data collected by Parker's solar probe had already provided the experts with some big surprises. In particular, the discovery of so-called switchbacks, short-lived, sharp bends in the particle streams of the solar wind that almost reject back to the Sun. How these structures are formed remained unknown for a long time, and in fact, it took another 3 years before the background to the mysterious switchbacks could be deciphered. And this was made possible with the friendly support of another spacecraft. When the solar orbiter, developed by ESA and NASA, made its first close flyby of the Sun in March 2022, it managed to capture one of these striking S-shaped switchbacks on film with its special camera. The data collected by the other probe instruments allowed the experts to analyze their accompanying phenomena and the exact circumstances, and it turned out that the solar wind switchbacks occur where open and closed solar magnetic field lines interact with each other. As a result, the field lines are reconnected. That is, the magnetic field undergoes an abrupt structural change, releasing large amounts of energy. The most extreme of these interchanges present themselves in the characteristic S-shape and appear in the measurements as magnetic field reversals. However, this was by no means the only solar mystery that the probe duo was supposed to solve. A few weeks ago, Parker's solar probe and solar orbiter actually examined one and the same solar wind stream at different distances, and thus played a major role in solving a decades-old solar wind mystery. Confusingly, the solar wind has the characteristic of not slowing down or losing energy with increasing distance, but of actually accelerating on its journey through space and cooling down significantly more slowly than it should theoretically. That this mystery is truly not a modern-day phenomenon is proven by the fact that astronomers in the 1960s were already trying to explain the impossible solar wind properties with a special type of magnetic oscillations known as Alfvén waves. These are basically capable of transporting energy in magnetic fields and also transferring it to the surrounding plasma. The discovered switchbacks, in turn, provided a first important indication of the actual existence of Alfvén waves in the solar wind, and a lucky coincidence finally provided definitive proof of this long-debated hypothesis. When the two probes were traveling independently in the same area, Parker's solar probe passed through the outer edge of the solar corona at a distance of only 9 million kilometers, while solar orbiter passed the plasma stream at a distance of 89 million kilometers. In other words, the probes studied the same stream at different stages of its journey from the Sun into space and revealed an exciting difference. Although the solar wind had the same total energy at both points, it was distributed differently. Expressed in figures, about 10% of the energy was still stored in the form of magnetic Alfvén waves near the Sun, while the proportion in the outer reaches was only about 1%. At the same time, however, the solar wind particles had gained the approximate missing amount of energy of 3.9 watts per square meter, which in turn had given them a speed boost and heated them up. And that is precisely the crucial point. The data show that the Alfvén waves must have transferred their energy to the solar wind and thus play the role of the long-sought anchor, accelerating the solar wind and causing it to cool more slowly than would be expected. And so it turns out that this research puzzle, which has kept scientists guessing for over half a century, can finally be put to rest. And if you haven't already done so, you can finally put your click to the subscribe button to rest. Feel free to click the thumbs up and subscribe now to never miss another new video from us again. We'll see you soon.